with low and high levels is usually the most pronounced here. As far as where it comes from, the majority of testosterone in the bloodstream is produced by specialized cells in the testes called Leydig cells. It forms when cholesterol within the cell is pulled into their mitochondria. Once inside, an enzyme turns it into pregnenolone, which exits to another part of the cell where it's converted into testosterone. How quickly cholesterol gets converted is controlled by luteinizing hormone, a hormone that binds with receptors in the Leydig cells. More luteinizing hormone means more testosterone production. Luteinizing hormone originates far off in the brain, specifically in a pea-sized gland called the pituitary gland. In men with low testosterone, the specialist will sometimes want to MRI this region to look for abnormalities. The release of this luteinizing hormone from the pituitary is itself controlled by receptors which, as you might have guessed, are triggered by yet another hormone called gonadotrophin-releasing hormone, which itself is released from neurons located in the nearby hypothalamus, which is the H in the HPG axis. What you barely hear talked about, though, is what areas of the brain can activate this chain. It turns out, a lot of them. I found a great academic review that outlines how senses of sight, sound, touch, and smell, as well as multiple brain areas involved in processing health and social information, have all been shown to not only activate the HPG axis, but also they can adjust receptor sensitivity at every level of it. This explains why so many different factors can affect testosterone. In some animals, it's seasonal cues that trigger group-wide level changes for their mating season. In others, it's their individual social status and health signals. It's also important to distinguish between a momentary spike and a long-term adjustment. Sudden temporary spikes occur in response to specific situations, since brain regions are able to recognize these events and trigger the HPG axis to release a burst. These are intended to cause just a temporary behavior change. For example, to influence the choice to respond to a sudden challenge by competing or backing down. With each spike, the brain watches to see how the situation plays out, and if the added testosterone leads to a favorable outcome, like say you do decide to compete and end up winning, it can upregulate the entire system. Over time, this can lead to long-term adjustments in the axis, shifting your baseline testosterone levels up or down, giving rise to the emergence of a distinct behavioral profile, for example, a dominant or submissive personality. While the temporary spikes tend to be studied more, as we jump now into the ways we can maximize our own levels, it's evidence for long-term changes that I'm going to mostly focus on.